November 8, 1942. Dawn breaks over the North African coast near Oran, Algeria. Operation Torch, the largest Allied amphibious operation to date, sends waves of American landing craft toward the beaches held by Vichy French forces. Among the 107,000 troops crossing from Britain and the United States are soldiers carrying a revolutionary new weapon that will change the course of anti-tank warfare forever. The American M1 Bazooka, officially designated the 2.36-inch rocket launcher M1, measures exactly 54.5 inches in length and weighs 13.1 pounds. Its tubular steel construction houses an electrical firing system powered by a 2-cell dry battery, capable of launching M6 rockets at targets up to 250 yards away. The weapon represents the culmination of work begun during the First World War by American rocket pioneer Dr. Robert H. Goddard and his colleague Dr. Clarence N. Hickman. Their November 1918 prototype had demonstrated the potential for rocket-powered infantry weapons, but the armistice ended development before battlefield deployment. Now, 24 years later, the concept has been perfected by United States Army Colonel Leslie Skinner and Lieutenant Edward Ewell, who created a delivery system for the M10-shaped charge grenade. When General George C. Marshall witnessed the first demonstration at Aberdeen Proving Ground in May 1942, he immediately ordered 5,000 units on the spot. Private First Class James Morrison of the United States 1st Infantry Division crouches behind a stone wall near Oran, his M1 Bazooka loaded with a 19-inch M6 rocket weighing 3.5 pounds. The rocket contains 8 ounces of pentolite explosive in a shaped charge warhead capable of penetrating 3 inches of rolled homogeneous steel. Morrison has received minimal training on the weapon, part of the hasty deployment that characterized Operation Torch. The night before the landings, General Dwight D. Eisenhower learned to his shock that none of his troops had received proper instruction in bazooka operation, a revelation that would prove prophetic for the weapon's mixed early performance. As American forces push inland from the landing beaches, they encounter French resistance that proves more determined than intelligence estimates predicted. The Vichy French forces in Morocco, Tunisia, and Algeria number approximately 125,000 soldiers equipped with coastal artillery, tanks, aircraft, and warships. The fighting that follows exposes both the potential and the limitations of the revolutionary American rocket launcher. The M6 rockets prove notoriously unreliable in the North African environment, their paper shell casings swelling in humid conditions and their temperature-sensitive propellant burning inconsistently in the desert heat. Despite these teething problems, the bazooka represents a quantum leap in infantry anti-tank capability. Unlike traditional anti-tank rifles that rely on kinetic energy to punch through armor, the M6 rocket employs the Monroe effect, a shaped charge principle that focuses explosive energy to create a plasma jet capable of burning through steel regardless of the projectile's velocity. This revolutionary approach means that a single infantryman can engage armored targets that previously required heavy artillery or specialized anti-tank guns operated by crews of 6 or more soldiers. The German response to Operation Torch comes swiftly and decisively. Within days of the Allied landings, Wehrmacht forces begin streaming into Tunisia to fill the vacuum left by withdrawing Vichy troops. Among these reinforcements are elements of the legendary Afrika Korps under General Feldmarschall Erwin Rommel, battle-hardened veterans who have spent 2 years fighting British and Commonwealth forces across the Western Desert. These experienced German soldiers represent some of the finest military formations in the world, equipped with advanced Panzer tanks, sophisticated anti-tank guns, and tactical doctrines refined through constant combat. Oberstfreiter Klaus Weber of the 10th Panzer Division's Reconnaissance Battalion encounters his first American bazooka during a patrol near Kasserine Pass in February 1943. The weapon appears crude compared to German precision engineering, little more than a steel tube with basic sights and a wooden shoulder stock. Weber examines the captured launcher with professional interest, noting its simple construction and lightweight design. The electrical firing system seems primitive compared to German weapons, relying on a battery housed in the wooden stock to ignite the rocket motor. Yet the weapon's potential is immediately apparent to anyone familiar with anti-tank warfare. The technical analysis conducted by Weber's unit reveals a weapon system that challenges fundamental assumptions about infantry armament. Traditional German anti-tank weapons like the Panzerbuchs 39 anti-tank rifle fire high-velocity rounds that rely on kinetic energy to penetrate armor. These weapons require precise marksmanship and become increasingly ineffective as tank armor grows thicker. The American bazooka operates on entirely different principles, using chemical energy from its shaped charge warhead to burn through armor regardless of impact velocity. The implications become clear during the Battle of Kasserine Pass, which erupts on February 19, 1943, when Rommel launches his offensive against inexperienced American forces. The United States Second Corps under Major General Lloyd Fredendall has positioned itself along the eastern dorsale of the Atlas Mountains, manning defensive positions that prove woefully inadequate against German combined arms tactics. The battle becomes a baptism of fire for American forces, exposing critical weaknesses in training, equipment, and leadership that cost 6,500 American casualties out of 10,000 total Allied losses. During the fighting at Kasserine Pass, German forces capture substantial quantities of American equipment, including multiple M1 bazookas and their associated ammunition. These weapons are immediately shipped back to Germany for comprehensive technical evaluation by the Heereswaffenamt, the German Army Weapons Office responsible for analyzing enemy equipment and developing countermeasures. The captured bazookas represent an intelligence windfall that will fundamentally alter German anti-tank weapon development. Hauptmann Friedrich Kellner of the German Army Ordnance Corps receives the first captured American bazookas at the testing facility in Kummersdorf during March 1943. His initial assessment focuses on the weapon's revolutionary approach to anti-tank warfare. The 2.36-inch rockets demonstrate penetration capabilities that exceed those of much heavier German weapons, achieving their effects through chemical rather than kinetic energy. The shaped charge warhead concentrates explosive force to create temperatures exceeding 6,000 degrees Celsius, hot enough to melt through steel armor like a cutting torch. The German technical evaluation reveals both the strengths and weaknesses of the American design. The M1 bazooka's lightweight construction and simple operation make it ideal for infantry use, requiring minimal training and capable of being operated by a two-man team. However, the weapon suffers from reliability issues, particularly with its battery-powered ignition system and temperature-sensitive propellant. The 250-yard maximum range also limits tactical flexibility, forcing operators to close to dangerous distances with enemy armor. German engineers immediately recognized the potential for improvement. The existing German 8.8-centimeter Raketenwerfer 43, a towed anti-tank rocket launcher, already employs 88mm rockets with proven shaped charge warheads. These RPZB Grove 312 rockets demonstrate superior penetration compared to the American 60mm warheads, capable of defeating 160mm of armor plate set at a 60-degree angle. The challenge lies in adapting this larger warhead to a portable shoulder-fired launcher similar to the American bazooka. The development project receives immediate priority from the German High Command, which recognizes the urgent need for improved anti-tank weapons as Allied armor grows more sophisticated. The task falls to German engineer Hugo Schneider and his team at Hugo Schneider AG, known as HASIG, one of Germany's largest armaments manufacturers. The company, founded in 1863 as a maker of metal goods and gas lamps, has grown into a major defense contractor with factories across Germany and occupied Europe. Dr. Hugo Schneider approaches the challenge with characteristic German engineering thoroughness. Rather than simply copying the American design, his team seeks to create a superior weapon that addresses the bazooka's limitations while maximizing its advantages. The decision to use the existing 88mm warhead from the Raketenwerfer 43 provides a significant head start, as these rockets have already proven their effectiveness in combat. However, adapting them to a shoulder-fired launcher requires extensive modifications to the rocket motor and firing system. The German development team faces several critical technical challenges in creating their improved bazooka. The larger 88mm warhead requires a proportionally larger rocket motor to achieve adequate velocity and range. This necessitates lengthening the motor housing from 490mm to 650mm, fundamentally altering the rocket's ballistic characteristics. The existing percussion firing system used by the Raketenwerfer 43 must be replaced with an electrical ignition system suitable for a portable launcher. Hazig engineers working under intense pressure develop an elegant solution to the ignition problem. Rather than copying the American battery-powered system with its inherent reliability issues, they design a magneto-driven firing mechanism similar to those used in aircraft engines. This system generates electrical current mechanically through the trigger mechanism, eliminating the need for batteries that can fail in combat conditions. The magneto firing system proves so superior that the Americans later adopt similar technology for their improved M9 and M9A1 Bazooka variants. The first prototype Raketen Panzerbuks 43, designated RPZB-43 and nicknamed Panzerschreck meaning tank terror, emerges from the Hazig workshops in Musewitz during the summer of 1943. The weapon measures 164 centimeters in length and weighs 9.25 kilograms when empty, significantly larger and heavier than its American inspiration. However, this increased size accommodates the devastating 88mm warhead that can penetrate 160mm of armor at combat ranges, more than double the penetration of the original American M6 rocket. The German weapon incorporates several improvements over the American design based on combat experience and engineering analysis. The magneto firing system provides reliable ignition under all weather conditions, while the larger warhead delivers superior anti-tank performance. The weapon's steel construction is robust enough to withstand the rigors of frontline service, and the 88mm caliber provides commonality with existing German ammunition production facilities. However, the Panzerschreck also introduces new challenges that its American predecessor avoided. The larger German rockets continue burning for approximately 2 meters after leaving the launcher tube, unlike American rockets that extinguish before exiting. This extended burn time creates a dangerous backblast that can injure the operator with burning propellant fragments. German soldiers quickly nickname the weapon Ofenrohr or stovepipe due to the copious smoke it produces during firing. The backblast problem forces German troops to adopt specialized protective equipment when operating the Panzerschreck. Operators must wear gas masks, protective hoods, and heavy gloves to shield themselves from burning propellant particles. This cumbersome protective gear reduces the weapon's tactical flexibility and makes rapid engagement of targets more difficult. German engineers work frantically to develop solutions, eventually adding a large protective blast shield to later production models in February 1944. Despite these operational challenges, the Panzerschreck's combat effectiveness exceeds all expectations. Test firings demonstrate the weapon's ability to defeat the frontal armor of any Allied tank in service, including the heavily armored Churchill and Sherman variants. The 88mm shaped charge warhead creates entry holes 2.5 centimeters in diameter, compared to only 1.3 centimeters for American bazooka rounds. This larger penetration creates devastating effects inside enemy tanks, typically killing or wounding the entire crew through spalling and secondary explosions. Production of the Panzerschreck begins in earnest during September 1943 at Hazig facilities in Musewitz and other German armaments factories. The company mobilizes its extensive manufacturing capabilities to meet Wehrmacht demands for the new weapon. Hazig operates factories in 8 German cities and 3 Polish locations, employing a workforce that includes thousands of forced laborers from concentration camps and occupied territories. By 1943, the company has become the 3rd largest user of forced labor in Europe, with over 41,800 workers in Poland alone. The rapid development and deployment of the Panzerschreck represents one of the most successful weapons programs in German military history. From initial capture of American bazookas in November 1942 to full-scale production beginning in September 1943, the entire process requires less than 12 months. This achievement becomes even more remarkable considering the weapon's technical sophistication and the wartime constraints on German industry. German production figures demonstrate the priority accorded to the Panzerschreck program. By the end of the war, Hazig and other manufacturers produce more than 310,000 Panzerschreck launchers of all variants, along with 2.2 million rockets. This production total dwarfs that of the competing Panzerfaust disposable anti-tank weapon, reflecting the German military's preference for reusable systems that provide better value per unit cost. The weapon's combat debut occurs during the Italian campaign of 1943, where German forces employ Panzerschreck teams against Allied armor advancing up the peninsula. The results prove devastating for Allied tank crews who have no effective countermeasures against the new weapon. Unlike traditional anti-tank guns that reveal their positions through muzzle flash and can be suppressed by return fire, Panzerschreck teams operate with guerrilla-like mobility, engaging targets and immediately relocating to avoid counterattack. Allied intelligence quickly identifies the new German weapon as a direct copy of the American bazooka, scaled up to accommodate a larger warhead. This realization provides both satisfaction and concern among American ordnance officers. The satisfaction comes from confirmation that their revolutionary weapon concept has fundamentally altered infantry anti-tank warfare. The concern arises from facing an enemy weapon that surpasses their own design in virtually every performance metric. The Panzerschreck's superior performance becomes painfully apparent during comparative testing conducted by American forces who captured German weapons in Italy. Corporal Donald E. Lewis of the United States Army participates in armor penetration tests using both the American M1 Bazooka and the captured German RPG-B-54 against a Panther tank. His subsequent report to American commanders states unequivocally that the Panzerschreck is far superior to the American bazooka in terms of penetration, reliability, and overall combat effectiveness. The German tactical employment of Panzerschreck teams evolves rapidly based on combat experience. Late-war German doctrine calls for anti-tank teams to establish positions in staggered trenches no more than 115 meters apart, ensuring that attacking Allied armor faces fire from multiple directions at ranges not exceeding 69 meters. This defensive system maximizes the Panzerschreck's effectiveness while minimizing exposure to Allied countermeasures. German training manuals emphasize the importance of targeting enemy tank side or rear armor whenever possible, where protection is typically thinner than frontal plates. Panzerschreck teams receive instruction in camouflage, concealment, and rapid position changes to avoid detection after firing. The weapon's distinctive smoke signature makes immediate relocation essential for crew survival, as Allied forces quickly learn to target Panzerschreck positions with artillery and small arms fire. The psychological impact of the Panzerschreck on Allied armored forces proves as significant as its physical effects. Tank crews develop heightened anxiety about operating in areas where German anti-tank teams might be positioned, particularly in urban environments where the weapon's short range becomes less of a limitation. Allied commanders find themselves forced to modify tactical procedures, requiring infantry support for tank operations and avoiding areas that favor Panzerschreck employment. Allied countermeasures against the Panzerschreck include adding improvised armor to tank hulls and turrets, such as sandbags, spare track links, and logs. However, these measures prove largely ineffective against shaped charge warheads that require approximately 1 meter of air gap to significantly reduce penetration. The standoff distance created by sandbags and similar improvised armor provides insufficient protection against the powerful German 88mm warheads. Some Allied units experiment with metal mesh and netting systems similar to the German Scherzenside skirts used on their own tanks. These systems show more promise but require extensive modification of existing vehicles and prove vulnerable to small arms fire that can destroy the protective standoff. The most effective countermeasure proves to be tactical rather than technical, emphasizing rapid movement, combined arms coordination, and aggressive suppression of suspected Panzerschreck positions. The Panzerschreck's success leads to its adoption by German allies and continued development of improved variants. Finland receives substantial quantities of the weapon in 1944, employing them with devastating effect against Soviet armor during the continuation of the Winter War. Finnish forces, already experienced in close-range anti-tank combat, prove particularly adept at Panzerschreck employment, achieving impressive kill ratios against Soviet T-34 and KV-1 tanks. Hungarian forces receive Panzerschreck weapons for use during Operation Spring Awakening, Germany's final major offensive on the Eastern Front in March 1945. The Italian Social Republic also employs the weapon against Allied forces in northern Italy, with several Italian units becoming renowned as skilled anti-tank hunters. These international deployments demonstrate the weapon's effectiveness across diverse combat environments and tactical situations. German engineers continue refining the Panzerschreck throughout the war, developing improved variants that address operational limitations identified through combat experience. The RPZB-54-1 features a shortened barrel and improved rocket design that increases effective range to 180 meters while reducing overall weapon weight. This variant enters limited production during the final year of the war but arrives too late for widespread deployment. Advanced development projects include proposals for manufacturing Panzerschreck tubes from Priesthoff, a paper pulp composite material that Germany uses extensively as a leather substitute due to raw material shortages. These experimental weapons would weigh significantly less than steel variants while maintaining adequate strength for combat use. However, the deteriorating military situation prevents full development of these innovative designs. The industrial achievement represented by Panzerschreck production becomes even more impressive when viewed against the backdrop of Germany's wartime economy. Hazig facilities operate under constant threat of Allied bombing raids while struggling with shortages of critical raw materials. The company's workforce includes increasing numbers of forced laborers from concentration camps and occupied territories, operating under horrific conditions that result in mortality rates as high as 1 death per 3.5 months at some facilities. Despite these challenges, Hazig maintains consistent production quality throughout the war. Captured Panzerschreck weapons examined by Allied technical intelligence teams demonstrate excellent manufacturing standards and reliable performance characteristics. The company's ability to produce complex weapons under extreme wartime conditions reflects both German industrial capabilities and the ruthless exploitation of forced labor that characterized Nazi war production. The Panzerschreck's development timeline reveals the impressive speed of German weapons innovation when properly motivated. From the initial capture of American bazookas in Tunisia during November 1942 to the first production weapons emerging from Hazig factories in September 1943 represents a development cycle of less than 12 months. This achievement includes comprehensive technical analysis, complete redesign of the weapon system, establishment of production facilities, and training of manufacturing personnel. Comparative analysis with Allied weapons development programs highlights the efficiency of the German approach. The American development of the improved M1 Super Bazooka, with its 3.5-inch warhead, requires several years from concept to production, entering service only in 1952 during the Korean War. The German ability to field an improved weapon within months of encountering the original demonstrates the advantages of focused development priorities and streamlined decision-making processes. The strategic implications of the Panzerschreck extend far beyond its immediate tactical impact. The weapon's development represents a fundamental shift in anti-tank warfare that influences military thinking for decades after the war. Traditional concepts of tank invulnerability to infantry attack become obsolete virtually overnight, forcing armor designers to develop new protection systems and tactical doctrines. The success of the Panzerschreck validates the shaped charge warhead concept that becomes standard for anti-tank weapons throughout the Cold War and beyond. Modern infantry anti-tank systems, from the Soviet RPG-7 to the American TOW missile, employ variations of the same basic principles pioneered by the American bazooka and perfected by the German Panzerschreck. The lineage of contemporary anti-armor weapons traces directly back to those first captured American bazookas examined by German engineers in 1943. The Panzerschreck also demonstrates the importance of industrial espionage and technical intelligence in modern warfare. The German ability to rapidly analyze, improve, and mass-produce an enemy weapon system provides a template for military reverse engineering programs that continues to influence defense acquisition strategies today. The speed and effectiveness of the German response to the American bazooka becomes a case study in adaptive military innovation. Production statistics reveal the enormous scale of German Panzerschreck manufacturing despite wartime constraints. The 310,000 launchers produced by war's end represent a significant investment in anti-tank capability, while the 2.2 million rockets provide sustained combat capability over extended periods. These numbers become even more impressive when considering that each launcher requires precision manufacturing to ensure proper rocket stabilization and accurate firing. The Panzerschreck's combat record validates the investment in its development and production. German anti-tank teams equipped with the weapon consistently achieve favorable exchange ratios against Allied armor, often destroying multiple tanks before being eliminated themselves. The weapon's effectiveness proves particularly pronounced in defensive operations where German forces can prepare positions and coordinate fires with supporting weapons. Urban combat provides ideal conditions for Panzerschreck employment, where the weapon's short range becomes less of a limitation and abundant cover facilitates ambush tactics. German forces defending cities like Cassino, Cannes, and Berlin employ Panzerschreck teams with devastating effect against Allied armor, attempting to advance through rubble-filled streets. The weapon's ability to penetrate any Allied tank frontally makes it a formidable close-range defensive tool. The psychological warfare aspect of the Panzerschreck proves as significant as its physical effects. Allied tank crews develop heightened caution when operating in areas where German anti-tank teams might be positioned, reducing the aggressive employment that characterizes effective armored operations. This defensive mindset among Allied armor units partially offsets their numerical superiority and technological advantages in other areas. German propaganda extensively promotes the Panzerschreck as a symbol of technical superiority and innovative thinking. Official publications describe the weapon as proof that German engineering can rapidly surpass any enemy innovation, turning captured weapons into tools for German victory. These propaganda campaigns help maintain morale among both military forces and civilian populations facing increasingly desperate military situations. The reality behind the propaganda reveals a more complex picture of German military-industrial capabilities under extreme stress. While the Panzerschreck represents a genuine technical achievement, its development occurs at enormous human cost through the exploitation of forced labor. The efficiency of German weapons production depends on a system of industrial slavery that produces weapons at the cost of tens of thousands of lives. Post-war analysis of the Panzerschreck program provides insights into both the potential and limitations of rapid weapons development under wartime conditions. The German success in improving upon captured American technology demonstrates the value of focused engineering efforts and streamlined decision-making processes. However, the human cost of this achievement serves as a sobering reminder of the moral compromises inherent in Nazi war production. The technical legacy of the Panzerschreck extends far beyond World War II, influencing anti-tank weapon design throughout the Cold War era. Soviet weapons designers study captured German examples to develop their own rocket-propelled grenade systems, while American engineers incorporate lessons learned from German improvements into their own weapon development programs. The cross-pollination of technical concepts accelerates innovation across all major military powers. Modern infantry anti-tank weapons trace their conceptual lineage directly to the American bazooka and its German derivative. The basic principles of shoulder-fired, rocket-propelled, shaped charge warheads remain fundamentally unchanged despite decades of technological advancement. Contemporary systems like the Carl Gustav recoilless rifle and various guided missile systems represent evolutionary improvements on concepts first proven in combat during World War II. The Panzerschreck's development story illustrates the complex relationship between military innovation and industrial capacity during global warfare. The German ability to rapidly reverse engineer and improve upon captured American technology demonstrates remarkable engineering capabilities operating under extreme constraints. The speed of development, from initial analysis to full production, represents one of the most successful weapons programs in military history. However, this technical achievement cannot be separated from the broader context of Nazi war crimes and the exploitation of forced labor that made rapid production possible. The Hazig factories that produced Panzerschreck weapons operated as instruments of industrial genocide, where tens of thousands of prisoners worked under conditions designed to extract maximum productivity before inevitable death. The weapon's technical success was purchased with human suffering on an industrial scale. The strategic impact of the Panzerschreck on Allied operations demonstrates how individual weapon systems can influence the conduct of major military campaigns. The threat posed by German anti-tank teams armed with the weapon forces changes in Allied tactical doctrines, requiring closer coordination between armor and infantry units. These tactical adaptations slow the pace of Allied advances and increase casualty rates among both tank crews and supporting infantry. The weapon's effectiveness also influences Allied equipment development priorities, accelerating programs to develop improved tank armor and countermeasures against shaped charge warheads. The threat posed by the Panzerschreck contributes to the development of spaced armor systems, explosive reactive armor, and other protection technologies that become standard features of modern main battle tanks. In the final analysis, the Panzerschreck represents both the pinnacle of German engineering innovation and a symbol of the regime's willingness to achieve military objectives through any means necessary. The weapon's technical excellence cannot be divorced from the human cost of its production, nor can its tactical effectiveness obscure the ultimate failure of the war effort it was designed to support. The 310,000 Panzerschreck launchers and 2.2 million rockets produced by Hazig and other German manufacturers represent more than mere production statistics. They embody the transformation of captured enemy technology into a weapon system that fundamentally altered the balance of power between tanks and infantry, creating tactical possibilities that persist in modern military doctrine. From the beaches of North Africa, where American soldiers first carried their revolutionary rocket launchers into combat, to the factories of occupied Europe, where German engineers perfected the concept into an even more deadly weapon, the story of the bazooka and Panzerschreck illustrates the relentless pace of military innovation during total war. It reveals how the capture of a simple steel tube in Tunisia could lead to developments that would echo through decades of military history, proving that in warfare, as in other fields of human endeavor, imitation truly can be the sincerest form of flattery.